Okay, so this is the exponential growth problem that I told you I was going to make you in the last video. So, you're buying a new TV for $750. You get a deal for no payments and no interest for 18 months. Awesome. Upon closer examination of your purchasing contract, you realize that if you don't make any payments, you end up being charged 2% interest per month. So we're going to write an equation for the total amount owed after X months. We're going to find the amount owed after 18 months if you don't make any payments. We're going to make a table and graph of our data. So we'll do the table and graph first. I think I'm going to make my table this way. So this is going to be months, and this is going to be the money that's owed. Okay? So in month 0, we owe $750. And then we have to figure out what to do. So again, this is sort of like the last problem where we have $750. If we multiply that by 0.02, which is 2%, that's $15. So I think we know that the $15 there is just what we're charged for interest for that month. We know that that's not the actual amount we owe. So we need to add that 2% into the 100% of what we already owe. So we want to put in 102%. So we're going to multiply by 1.02. So if we think about our equation, that would be y equals, again, we're going to start with 750. And instead of multiplying by 0.02, we're going to do 1.02 to the x. That's our equation. Cool. So I'm going to take my 750 and I'm going to multiply it by 1.02. And that's going to give me, at the end of month 1, I'm going to owe 765. At the end of month 2, I'm going to multiply by 1.02 again. That is not what I just did. Sorry, 765 times 1.02. I did 0.102. So that's going to be 780.30. Okay, so if we look, you can see in the first month, it goes up by $15. In the second month, it goes up by a little more than $15. And then in the third month, we have $795.91. So again, a little more. This one is $15.30. This one is $15.60. Yeah. And then in month 4, we're at $811.82. So now we've gone up almost $16. Yes? So you can see we're going up a little bit more each time. So for 18 months, I can keep multiplying by 1.02, or I can just make this 18. I can, yeah. Sorry. So for that, I'm going to do 750 times 1.02 to the 18. So then at the end of that, I'm going to get y equals 1071.18. So at the end of the 18 months, if I don't make any payments, I actually have picked up over $300 in interest. That is a lot for thinking that I wasn't accruing any interest. And I didn't have to make any payments. So that is a huge gimmick for marketing. Don't let them trick you. Yeah, just don't let them trick you. Alright, so I'm going to make my graph, and again I'm going to go like 500, or let's go 250, 500, 750, 1,000. So I start here, and then I'm going up a tiny bit at a time, and then it starts to go up a little faster. So that's going to make a curve like this. It's kind of hard to see that it's curving because it's not changing a whole lot. If we were going up $15 a month times 18, that would be 270. Instead, it went up by like 320. So it's hard to see here that it's curving, but it would curve a little bit. If we wanted to know, like, let's say that partway through they extended it and said, hey, you actually only need to go for, you don't need to make any payments or have any interest for 36 months. So in that case, we would do 750 times 1.02 to the 36th. Hold on, I made a mistake. Let's try that. No, let's try again. To the 36th. So that's 1529.91. So now it's gained $600 or over almost $500 more in interest. So it starts to go up a lot quicker. It's hard to see because 1.02 is tiny. But that is how that works. So exponential growth. We know it's growth because it's going up. We show that in our equation by having this number be bigger than 1. If it was smaller than 1, if we were saying that it lost 2% of its value every month, we would be multiplying by 0.98. So, let me erase all of this. So, for growth, you do 1 plus your percent. For decay, you do 1 minus your percent. Okay? So that's totally fine. You guys can do that. And then the other thing we want to talk about is how we tell if something's linear change or if it is exponential change. How we figure out if it's which one of those it is. And the only things we're going to care about in this course for Summer School Algebra 1 is it linear change? Is it exponential change? Or, sorry, is it neither one? So, if we have x, we have y1, we have y2. We'll do another one. We'll do y3 just for good measure. Okay, so x is, let's do -2, -1, 0, 1, 2, 3. Okay, so I'm going to make this, we'll make our starting value 5 for all of these, okay? So for this one, let's say we're going to have 9, and then 13, and then 17, and no, +1 and -3. For this one, we're going to have 10, 20, 40, 2.5, and 1.25. And for this one, we are going to have 5, 6, 9, 14, 6, and 9. Okay, so we want to know if these are, so one is linear, one is exponential, one is neither. So the first thing we should notice is for linear and exponential, it's either growth or it's decay or decrease. It can never be both. So that tells you right away that y3 is neither. Get away. That tells you that y3 is neither because it increases and decreases. As we move, you can see it goes down by 3, and then it goes down by 1, and then it goes up by 1, and then it goes up by 3, and then it goes up by 5. Yes? So you can see it's not doing both. It's decreasing and increasing. Doesn't work. Can't be exponential or linear. All right, so then we look at y2, and we can see that it's always increasing as we go. And we're going to look for a pattern. So if you look at y2, you should see that it's doubling each time you're multiplying by 2. If you're always multiplying by the same number, that's exponential. Remember, the exponent tells you how many times the thing is multiplied. So that tells you it's going to be exponential because you're multiplying by 2 over and over and over and over again. When we look at y1, you can see that you're adding 4 each time. That's linear. That's a linear pattern. You add the same amount each time. Yes? So for linears, you always add the same amount. For exponentials, you always multiply by the same amount. Anytime that you're given like a percent increase or a percent decrease, that's always going to be exponential, because the amount that you are finding the percent of is going to continually change. And so that's going to cause your value to continue to change, which is what you're looking for an exponential. Okay? That's it. That's everything you guys need to know for exponentials. Growth, decay, writing the equation, making the graph. Growth, decay, writing the equation, making the graph, answering questions, and determining if it's linear or exponential growth or neither. That's all you have to do. All right? You guys are going to do awesome on this, just like everything else. I know it. I'm excited to see how you do. Bye.